In example 2, we will look at how to graph a parabola without a graphing calculator that is in y equals ax squared plus bx plus c form, okay? Now, some books call this standard form, some books call this general form. I don't want to confuse you, so I will just say it's that form, okay? Now, if you take a look, a is the leading coefficient. I can see a is -1, right? -1 is a number in front of x squared. So a is -1. What is b? B is the coefficient of the linear term. What's in front of x? And that is +6. I'm not going to do quadratic formula in this video. So for this example, a and b is fine. But if you want to know what c is -5, right? I'm not going to use c. But you will need to identify what a and b is to do the vertex down here, okay? Now, first of all, does the parabola open upward or downward? What do you think? Leading coefficient a is -1, is negative. So it opens downward. For equations for quadratic functions that are in this format, I'm going to give you a very useful formula that you can use. It's called a Vertex Formula. If you ever need to find a vertex of a quadratic function written in this format, say that x coordinate is equal to -b divided by 2a. This is something that I will write down on a formula sheet or just memorize, okay? But we know what a is, we know what b is, so let us plug in these two numbers to identify what the x coordinate of the vertex is, okay? So on top of the fraction, I need to do -b. Because b is +6, negative of +6 is just -6, right? Now in the bottom of the fraction, I have to do 2 times a. 2 times a is -1. All right, I'm going to go ahead and evaluate what this is. I will have -6 divided by -2, and negative divided by negative is positive. So what we just found is the x coordinate of the vertex, right? Now, I need to find the y coordinate of the vertex. Okay, to find y, plug in that x value that you just found into the function. Okay, because vertex formula will only find you or get you the x coordinate of the vertex. So if you want to find the y, just plug in that x that you got into the function. If I evaluate this, I will get -9 plus 18 minus 5. That is 9 minus 5, so I will get 4. So we have a vertex at 3, 4. I've noticed there is a common mistake some people make. Some people say that the vertex is at, -6, -5. I think I know what they're doing. I think they are thinking this is a form, this is an equation transformation form. No, it's not. This is different from y equals -x plus 6 squared minus 4, okay? It's different form. So you have to be able to identify two different forms of quadratic function. If you have ax squared plus bx plus c form, if you want to find the vertex, you have to use this vertex formula, okay? Let me plot this vertex on the graph. I have 3 to the right, up 4. Oh no, I was so worried. Why? Because it's already up there. And I was like, what if I have a graph that looks like that? But no, I don't have to worry because we know this graph will open downward. So I'm probably going to have something that looks like this, right? All right, after plotting the vertex, I'm going to go ahead and sketch a vertical line here. Why? Because vertex is where that magic happens. This is where the graph is perfectly symmetric about. So everything to the right of this red dotted line will be a mirror image to the graph to the left of this red line. Okay, of course they're asking you for the axis of symmetry equation. Here's how you write the wrong answer. Like people know, okay, axis of symmetry is the x coordinate of the vertex. So they just say 3. Now that's still good, but if they want the equation, you have to give them an equation. So what equals 3? Okay? And you know, I always kind of tell you the hint is X is symmetry. So say X equals 3 because the equation of a vertical line is always X equals a number. It will be wrong to say Y equals 3 because Y equals 3, guess what it looks like? It looks like that as a horizontal line. So make sure when you are giving the equation for axis of symmetry, say X equals the X coordinate of the vertex. Now, does this function have a minimum or maximum value? Okay, we know this graph, this parabola, opens downward. Graph looks like this. So if it's an upside down U shape, we have the highest point, right? Which means this parabola will have a maximum value. And that maximum, we're staring at it right here. That maximum is this point right there, okay? Vertex is a very special point in the parabola, okay? All right, where does that maximum value occur? That's what the next question is. And I almost made a mistake on the first video. When they're asking for where that happens, I'll tell them the x coordinate of the vertex. And x coordinate of the vertex is 3. X equals 3. And the next question it asks, what is the actual maximum value? The function's maximum value. And you know how I'm crossing out the word minimum? Because this function will not have a minimum, right? It will have the highest point, and that's a maximum. And the highest point, you know, the parabola will look something like this. So the highest point, the y value, the highest y value will be 4. So I'll tell them the maximum value is 4. And you know this is the y coordinate of the vertex. Okay, now let's do the domain and range of a quadratic function. If you watched the first video, you know domain of any quadratic function is always all real because you can square any number, but range is different there, right? Now, if I just do a quick sketch of this graph, notice this graph will open down forever, right? Open down, it's going to go down forever. So the lowest point of this graph will be negative infinity. Well, how high does it go? What's the highest point of this graph? 4. But it does have a value at 4, right? So what I'm going to do is I'm going to draw a bracket after 4. It will be wrong to say negative infinity to 4 with the open parenthesis, because if you do that, you are telling them that, oh, the graph doesn't touch 4. Okay, it goes really, really close to 4, but it does touch 4. So what I will say is it needs to have a square bracket, and that is the range for this quadratic function. Okay. I showed you how to find y and x intercept algebraically, and I will do the same on this example. Because I know you guys have calculator, graphing calculator, Desmos, but we should still be able to do them without a graphing calculator, and it's not that hard. So to find the y-intercept, you set x equal to 0. Okay? If you want the y-intercept, plug in x equals 0. So that will be y equals negative 0 squared plus 6 times 0 minus 5. And the first two, these two all turn into 0, so the only thing left is negative 5. So you will plot a y-intercept at 0, negative 5. So I'll do that, okay? Let's plot 0, negative 5. 0, negative 5 is down here. Now remember that axis of symmetry, right? This point right here is 3 to the left from the axis of symmetry. So if I want to plot another point, I will go 3 to the right from that axis of symmetry. So I know I will have a point as 6, negative 4, negative 5. Okay? All right, let's go find the x-intercept this time. X-intercept happens when y is equal to 0. So I'll say this function, I'll just set y equals 0. Okay, so say 0 equals negative x squared plus 6x minus 5. And this is where some people may get uncomfortable because we're going to have to factor. Now notice the leading coefficient is negative. So what I will do is I will factor out the negative. What will happen is everything, all terms in this trinomial will change the sign. Negative x squared will turn into positive x squared. Plus 6x will turn into minus 6x. Minus 5 will turn into plus 5. That is how we factor out a negative 1 from all of these. What I did was we really just divided each term by negative 1. Now, after that, I'm going to factor that trinomial inside. So just focus on this trinomial inside. Let's try to factor this, okay? What times what is 5? 5 times 1 is 5, right? But if I make both of them negative, not only negative 5 times negative 1 will multiply to be positive 5, but I can add negative 5 plus negative 1 to get that minus 6. So this is how we factor this green highlighted trinomial. Now we set each factor equal to 0. X minus 5 equals 0, and x minus 1 equals 0. And what we are doing right now at this point is called zero product property. I get to say that because if one of these parentheses is equal to 0, them multiplying together will end up as 0. So if I solve the first one, I get x equals 5. If I solve the second one, I will get x equals 1. So we just found 2x intercept. Plot 5, 0, and plot 1, 0. These are your x intercepts. Okay, let's go plot 5 and 1 on the x-axis. 5 is here, and 1 is here. And I love this because take a look. This point is 2 to the right from the vertex, and this point is 2 to the left from the axis of symmetry. I should not have said vertex. I should have said 2 to the right from the axis of symmetry and 2 to the left from the axis of symmetry. So it forms a perfect symmetry. So this is good. I'll go ahead and connect these 5 dots to create a beautiful parabola. Okay, so we did it again. We graphed another parabola without the help of a graphing calculator. But if you are doing your homework problems, if you want to check and see if you're doing all these right, definitely go to desmos.com and graph it, and you should be able to also, let me see, if I go ahead and use my Desmos graphing calculator app, I can do y equals negative x squared, y equals negative x squared, oh, I forgot the rest of it, plus 6x minus 5, plus 6x minus 5, and we'll see that this graph truly does have an x-intercept at 5, 0, x-intercept at 1, 0, and a y-intercept at 0, negative 5, vertex right there at 3, 4, and if you want to get some table of values, I click on this edit list, click on the table, and it's going to give you a whole bunch of points that you can plot. So I think Desmos graphing calculator is a wonderful tool that you can use to check your answer. But I want all of you to be able to still do this without the help of a graphing calculator, because you can, okay? So we did finish this, but I do have just one more last part, okay? It's about using the vertex to write this quadratic function in this form. And this is the big idea that we will come back to for our second topic. But if I were to just do this real quick over here, we want to rewrite our function in that form, okay? I'll go ahead and write this a little bit bigger. We want to rewrite this function in f of x equals a times x minus h squared plus k form. We know what a is already. A is negative 1. A is negative 1, okay? I'm going to tell you what h is. H is the x-coordinate of vertex. What was it? Let's go look it up. X-coordinate of the vertex is 3. So say h is equal to 3. All right. The next part that you need is k. Because take a look. We just need to plug it in. A goes here, h goes here, and k goes right there. So I'll tell you what k is. K is the y-coordinate of vertex, which I need to go back up and find. Okay, let's see. The vertex was 3, 4, so y-coordinate is 4. So I'm going to have to plug in 4 into K. Now, we have everything that we need to plug in. Okay, so let's go ahead and start plugging in. Okay, f of x equals, what's a? A is negative 1. Negative 1 times x minus, what's h? H is 3. 3 squared plus, what's k? K is 4. And we're done. Okay, so there's really two methods that I need to show you in a different video. Okay, in the next video I will show you how you can rewrite an equation that is given in ax plus bx plus ax squared plus bxe plus, I just want to call it standard form. An equation in standard form. We're going to do something to put this in vertex form, and you just learn how to do that really. Okay, if you know what a is, what x and y coordinate of the vertex is, we can easily put this in vertex form. But there is another method that I have to show you. It's called completing square method. I want to sometimes skip it because vertex formula method is so easy, right? But completing square method will be very useful when we solve quadratic equations later in the chapter. So I will show you both methods, but that will be for the next video. So I will stop this one here, okay? We talked about a lot of different things in this second video.